This video will serve as a short review for rotational trigonometry. Rotational trigonometry is when we determine the trigonometric ratios of angles on the Cartesian plane. And so angles produced on the Cartesian plane are done so using what is called a terminal arm. Okay, and so the terminal arm is what we see right here in blue. So I'll just notate that right here. That is your terminal arm. Okay. And the angle in standard position is the angle that terminal arm makes when it rotates in a counterclockwise manner. Okay, and it's the angle it makes with the x-axis. So that right there is called the angle in standard position. Note again, this is counterclockwise rotation from the positive x-axis. And this angle, if it's in standard position, is always positive. R, as seen right here, is the length of the hypotenuse. And you can determine R by calculating the square root of x squared plus y squared. And note that R is always positive. So if theta is the angle in standard position, then the angle the terminal arm makes with the x-axis, the acute angle rather, that the terminal arm makes with the x-axis is called the related acute angle, or RAA for short. And the related acute angle is the angle that it forms with the terminal arm and the x-axis to produce this right-angled triangle here. When we have these angles, we can then redefine sine, cos, and tan. Sine theta is y over r. Cos theta is x over r, and tan theta is y over x. So sine of theta would be the y value opposite over hypotenuse, y over r. The cos theta would be x over r, because that would be adjacent over hypotenuse in the triangle produced by the related acute angle. And then tan theta is y over x, so opposite over adjacent in the triangle produced by the related acute angle. It's also possible to have angles that represent more than one full revolution or negative angles. We can deal with them in the exact same way as other angles. So counterclockwise rotation, as we said previously, indicates a positive angle. So when you go counterclockwise from the positive x-axis, you have a positive angle. If you were to do clockwise rotation, okay, so if I was to go clockwise from the positive x-axis, that would be a negative angle. Oh, that's off the screen, so negative angle right there. So two angles in standard position that have the same terminal arm are called coterminal angles. For example, 420 and 60 degrees are in standard position are coterminal angles because they end up with the same terminal arm. So 60 degrees, you rotate and you end up over here, and 420 degrees is simply 360 degrees plus another 60 degrees, and therefore they are called coterminal angles. If we were to determine the exact value of sine of 570 degrees, well, 570 degrees definitely includes one full rotation. So what I'm going to do is I'm going to go 570 degrees. I'm going to subtract a full rotation from that. And what I should get from there is 210 degrees. Okay, so that means it's going to be coterminal with 210 degrees. So 570 degrees, that's positive, so that means I'm going to go 360 degrees and then another 210. So I will end up right here. That's where my terminal arm will be. It's going to be in the third quadrant, okay? And then my related acute angle is going to be 30 degrees right here, which means that this angle right there is 60 degrees, and that produces a 30, 60, 90 special triangle. This would be negative root 3, this would be negative 1, and that is 2. So sine of 570 degrees is equal to y over r, which is equal to negative 1 over 2. If we wanted to determine the exact value of tan negative 5 pi over 3, what we'll have to do there, first what I'm going to do is I'm going to draw a Cartesian plane right here, just sketch one out pretty quickly. And then 5 pi over 3, well that means 5 times pi over 3, and pi over 3 is 60 degrees, so that's actually equal to 300 degrees. So 5 pi over 3 is equal to 300 degrees, therefore negative 5 pi over 3 is equal to negative 300 degrees. So that means my rotation is going to go clockwise from the positive x-axis 300 degrees. So I go 300 degrees right here, okay? And so I'm going to write that as negative 5 pi over 3, and then I draw my terminal arm right here. Knowing that it's negative 300, that means that inside there, my related acute angle is going to be 60 degrees, so that means that's going to be pi over 3, which means that this angle right there is equal to pi over 6, okay? And that's your 30 degrees, that's your 60 degrees, so that's a 30, 60, 90 triangle, which means that this is root 3, that is 1, and that is 2. So tan of negative 5 pi over 3 is equal to y over x. Y in this case is root 3, x in this case is 1, so that's simply equal to root 3.